These are the full explanations to the problems on the quiz from 1-5 to 1-7. Problem 1a, z over 5 is equal to 3/10 z plus 7, is actually just a two-step algebraic equation, like you learned in Algebra 1. The only thing is that these have fractions. So I'm going to show you two different ways of attacking this problem. One of the ways is that it's 1/5 z, if you didn't know that. Z over 5 and 1/5 z, same thing. Then you could subtract 3/10 z from both sides, and then in your calculator 1/5 minus 3/10 is negative 1/10. And then you would divide both sides by negative 1/10. Now when you do that in your calculator, it should look like this. And you should find out the answer is negative 70. Another way, though, that you could have approached this problem is if you don't like fractions, what you should do is find the least common denominator of all the three denominators. Well, 5, 10, and 1, the least common denominator is 10. So if I multiply everything by 10, I can make the fractions go away. I'm left with 10z is equal to 3z, nope, let's go back, not 10z, 2z, because 10 times a fifth is 2. 2z is equal to 3z plus 70. Then I would subtract 3z, and I get negative 1z is equal to 70, so z must be negative 70. B is just a proportion. How do you solve proportions? You cross multiply. So let me start here and cross multiply. I get 10x minus 5 equals, and then I'm going to cross multiply here, 4x plus 8. And now this is an equation you can solve very quickly. You should get 6x minus 5 is equal to 8. So 6x is equal to 13, which is why x was equal to 13 over 6. If you turned it into a decimal, but you got that answer, it's all cool. In problem C, this was a quadratic equation. Hopefully you learned in Algebra 2 how to graph this and determine the solutions. If you graph this parabola, you will see the graph hit the x-axis at 2 locations, and then there is a function on the calculator that finds the zeros. The problem with the calculator is that it will always give you the decimal zeros when the answers are irrational. But what if I want the exact answer? Well, I could have always used the quadratic formula. So I'm going to rewrite this in descending order of powers. And the only reason I'm going to do that is because now I know that in the quadratic formula, A is 1, B is 5, and C is 3. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I evaluate what's under the radical first. 5 squared minus 4ac is going to be 13. And I can't take the square root of 13 because it's irrational. We just leave the answer like this. Absolute value equations always produce two answers. The reason they produce two answers is because the absolute value of a positive is a positive, and so is the absolute value of a negative. So in order to solve this, what we do is we set up these two equations. 3x plus 5 could be positive 1, because the absolute value of 1 is 1. But 3x plus 5 could also be negative 1, because when you take its square root, you'll still get positive 1. And then you just solve these. So 3x is equal to negative 4, x is equal to negative 4/3 is one of the solutions. 3x is equal to negative 6, and x is equal to negative 2 is the other solution. For problem number 2, in order to do these mixture problems, we're going to make ourselves a little chart to help us organize the data. So Wendy took a trip from Davenport to Omaha, a distance of 300 miles. She traveled part of the way by bus, which arrived at the train station just in time for Wendy to complete her journey by train. And it should have said the bus averaged, but if you knew it was the train that averaged, you could figure it out. The other one must be the bus. The bus averaged 40 miles per hour and the train averaged 60 miles per hour. The entire trip took 5.5 hours. How long did Wendy spend on the train? This is a distance equals rate times time problem. So make myself distance, rate, time. One of them is going to be for the train, and one of them is going to be for the bus. All right, so let's start with the time the bus traveled, because we want to find out how long she was on the train. I don't know how long she was on the train. Let's call it T for time. So she was on the train for T hours. She must have been on the bus for 5.5 minus T hours. The rate the train traveled was 60 miles an hour. And the rate that the bus traveled was 40 miles an hour. The total distance, that means when I add the two distances together, it will be 300. So 300, oops, let's make that look nicer. 300 must equal the rate times the time for the train, which is 60 times t, plus the rate times the time for the bus, which is 40 times 5.5 minus t. Once we get to that equation, now you should know how to solve it. We're going to distribute. We're going to combine like terms. I'm going to run out of space here. I'll write it down here. So 300 is equal to 20t plus 220. I'm going to subtract 220 and get 80. And then I'm going to divide by 20, and I find out that t is 4 hours. And since t was my time on the train, it must have been 4 hours on the train. For problem number 3, in order to solve this inequality, what we're going to do is we're going to put this portion of my inequality into the graphing calculator. You're going to graph it just the way it is. You don't even have to multiply it out. Because what we want to do is we want to look at the portion of the graph that's less than 0. So when I graph this on my calculator, because it's a quadratic, I get a parabola. Well, in that parabola, which portion of it is less than 0? The portion that's less than 0 is the portion that's under the x-axis. This is where they're negative. Well, where is it negative? Well, it's negative from -2 until +3. That's a compound inequality. So this is the answer. The reason that I chose the inequalities without the lines underneath is because the original problem was just less than, not less than or equal to. So when I wrote my compound inequality, it looks like this. Now, if I had now this is the answer to the problem, but I'm going to change it for a second to show you another thing. Let's say instead I gave you x plus 2x minus 3 is greater than 0. I would be asking you for where it was above the x-axis. So it would be above the x-axis here and here. I would have two non-connecting portions. Think about this in terms of graphing things on the graph on the number line. When we graphed things on the number line back in Algebra 1, this was called a compound inequality. A compound inequality is one where you would have two circles on the graph, and then you would just connect them. It was also known as an AND statement. But the one I did in purple here, when they're not connecting, when it looks like this, that was called an OR statement. So the solution, if instead this problem had said greater than 0, would have been x is less than -2 or x is greater than 3. Because the inequality symbols you use sort of have to match the original problem. And those are the detailed instructions for the quiz from 1.5 to 1.7.